Vibration case study 4.1. So we want to look at limiting wind-induced loadings. If you take a look at smokestacks that exist, newer ones will have these very cool spirals on them. They're pieces of steel that are welded onto the side. And older ones will have these kind of interesting brick layer shapes. And sometimes they'll even have curved brick around the side. You'll see some people talk about, oh, people used to take pride in their work and this, that. No, not really. Smokestacks were always built for industry to do a job for the least amount of money. But those bricks played a very important role. So what happened when we first built smokestacks, we built them to create hot fires, to pull heat up. And you would build a big smokestack because if you didn't, you would wake up in the morning and sadly, entire towns would die, right? Because during the Industrial Revolution, you would just drop a bunch of pollution on your town. So dilution is the solution to your pollution. You pump it up higher, you get it to dissipate out over a greater area. So we did that. The wind tunnels, the smokestacks get higher and they start to fall down, right? And one of the reasons they fall down is if you have something that is of a consistent, that's not very consistent, if you have something that is of a consistent diameter, you'll start to get oscillating wind currents that form around that and vortices, right? I'm sure you've seen those videos and pictures of vortices forming. It's a vibrations class. Why does it matter? Those vortices introduce small loadings onto the smokestack. We consider a lot of times wind to have a lot of different frequencies in it, a lot of different speeds. When wind hits the right speed, it will hit the right resonance of that stack. And because that stack is one diameter the entire way up, it will all start to put energy into the system at that resonance, and the whole thing will come crashing down. And brick isn't very good at absorbing a lot of vibrations, right? It doesn't bend. It's not very strong. You know, bricks are strong in compression, but if you get mortar between two bricks, you can relatively easily pull them apart. You know, not all the time. Sometimes you can get really good mortar jobs, but you get one bad mortar layer and the whole thing can come crashing down. Okay, so how can you solve this? You can make exaggerated, but you can make your smokestack to be tapered. What happens if it's tapered? The frequency that you're inducing at one part of the smokestack is going to be different than the frequency you're inducing at another part of the smokestack. So a single point of that smokestack will be excited at the wind of the speed, which may be in resonance for that part of the smokestack, but the part above it will be below resonance, and the part above it will be above resonance, or vice versa, right? And so this is a way to keep energy out of your smokestack at that specific speed. When you move away from building smokestacks out of brick, you start to build them out of steel, and these become another way to break up the vortices, right? They're slightly different solutions to the same problem. In one, you're breaking up the vortices and you're shedding them. In another, you're absorbing the energy at multiple frequency components, right? There are other reasons to taper a smokestack also. There are thermal reasons, kind of combustion reasons. It's a vibrations class, so we're just going to focus on the vibrations reasons of why you want to taper a smokestack. This also exists in power poles. One of the ways that they deal with this in power poles is you actually hang a chain down the middle and let a chain free float, because that chain will act a little bit as a tuned mass damper, and will also kind of absorb a little energy, right? Absorb that energy, and the heat it dissipates into the heat inside the light pole. So something cool to think about in the design of the structures that are around us, particularly as you're trying to keep these tall structures from entering resonance and falling down. And some of these smokestacks now have stayed up, 100 or 200 years, and it's a pretty successful solution.